In this question from the chapter Permutation, it says how many different words can be formed with the letters of the word Haryana. So that means you can see in this Haryana how many letters are there. It's 1, 2, 3, 4, 5, 6, 7 letters words are there. And this 7-letter word can be arranged in 7 factorial ways. And further, you can see that here A is being how many? A is 3 times. A is 3 times. So that divided by 3 factorial. I'm using this relation n factorial into n1 divided by n1 factorial into n2 factorial. So we can conclude that this is what? This is, if I do the final calculation here, this is what? 7 into 6 into 5 into 4 and 3 factorial get cancel here. So the calculation will come as 7 into 6, 42 into 4. So 42 into 4 and that multiplied by 5. So that comes out to be 840. So 840 is the answer for the first part. Now, as we read the next part, it says that how many of this has H begins with H. That means the first letter is H here and ends with N. So these two letters are fixed and I can now see that we are left with 5 more slots. And these 5 letters word can be arranged in 5 different ways, that 5 factorial ways. Further, as you know that here we haven't fixed A here. So that means A remains 3 times 3 identical object. So this is what 5 into 4 into 3 factorial, that divided by 3 factorial. So this get cancelled, comes out to be 20. Now coming to the last part, the final part, it says H and N are together. That means wherever is H and N, it is together. Now let's figure out how many places that H and N can have. This is how many places can H and N together. So let's see why it's got displaced. Right, continuing with the last part, this is H and N are fixed here. Now check here, if we fix H and N, let's figure out they are together, right? Not fixed, they are together. So how many positions that H and N can have? This is placement 1. Then this is the second position. This is the second vase, third vase, fourth vase, fifth vase, and sixth vase. It cannot go beyond that, right? So once again, this is 1, 2, 3, 4, 5, and 6 ways. Now further H and N can swap. So we can first of all figure out that H and N can be arranged in 6 ways. Further, they can swap each other's position like H, N in the beginning and later it is H. So 6 into 2, that is 12 ways. Now considering the other slots, which are again 5 of them, they can be arranged in 5 factorial ways. Further, we know that letter A, which is not considered, can be, these are 3 identical letters, that is A. Therefore, it is 6 into 2, 12, and this we have calculated as 20. So 12 into 20, that is equal to, is how much? 240. It's 240. So the answer for the last part will be 240. For the second part, it was 20. And for the first part, it was 80. So that's how we got the answer for this.